Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem better string. So this is a hard level question, and the topic tags are the company tags haven't been given, but the topic tags are strings, dynamic programming, recursion, data structures, and algorithms. And I also got to know that this question has been asked by the companies like Disney, Hotstar, and Urban Company, and even Samsung as well, and many other companies are also there. All right, so let us go to the question now. So given a pair of strings of equal length, already been declared, it's of equal length. Geek wants to find the better string. So what is the definition of a better string? The better string is a string having more number of distinct subsequences. All right. So each and every string can have various possible number of subsequences. In that, some of them could be distinct, some of them could be repeating. So you need to find the string which has more number of distinct. Okay, all the subsequences that you are going to frame must be distinct. If both of the strings have equal count of distinct subsequence, then return the string 1. All right, so string 1 has been given, string 2 has been given. So in the example 1, example 2, so we'll be going through those examples later. And what is the time complexity? O of maximum of string 1 length and string 2 length, already given that both of them will be having of same length. The strings will be of same length. So in this case, it's like O of n, where n is the length of the string. Same is the case with expected auxiliary space, O of n, like string 1 length and string 2 length. Maximum is both values are same, so O of n. All right, and string 1 length and string 2 length can go up to 30, from starting from 1 to 30. So you can understand how minimal the constraint is. So you could actually use many methods and you can usually find them, but what I have tried to use is somewhat different. I think this is much more optimal and is according to the constraints that have been given to us. All right, so there might be other methods as well, so I do not want to spend some time on it and increase the video length. Rather, it's better if we stick to the most optimal approach, so learn from this. But I do not encourage this. It's always better to learn many approaches, but in my present video I'll always go with the optimal solution. Okay, so going to the examples, we have string 1 to be GFG and string 2 to be GGG. Okay, but the output is GFG. Why? The reason being, GFG have 7 distinct subsequences, whereas GGG have 4 distinct subsequences that have been given in the explanation. Let us now illustrate that. So GFG. So what are all the subsequences possible for this particular GFG? So we have G, we have this particular GF and F, and we have particular GG, GFG, FG, and G. All right, so I'll explain how did I come to this conclusion, how am I writing all these subsequences later if you do not understand this. Right, as of now, let us just list out the subsequences possible. So how many distinct are there? G, GF, F, GG, GFG, FG. Right, only 6 I find. 1 2 3 4 5 6. I think this must be 6. Please let me know if I'm wrong. I don't feel there's any other subsequence that has been left out and distinct from this particular thing, because this G has already been repeating here. All right, so GFG must be the answer. Now what about GGG? So we have GGG. So what about GGG? We have G, and we have GG and G, and we have GG, GGG, and G, G, and G. All right, so a lot of subsequences here. So how many unique are here? Again, we have G to be unique, so these two will be exempted. GG, we have this to be exempted, and this GGG. So total 3. Again, this must be 3 here. Please let me know. Okay, I'm stressing on this. Please let me know. I don't think that I'm actually leaving anything apart. I think everything's being covered here. Every subsequence possible. So there are 3 subsequences that are distinct. All right. So both of them compared. Here we have 6. Here we have 3. So that's the reason GFG will be the answer. I hope you people understood. Now coming to the second thing. So here str1 is a, so number of distinct subsequences is only 1, and here as well str2 equal to b, so number of subsequences would be equal to 1 equal to 1, right? So in that case, return the string 1 as given in the question. Return string 1. So I hope you people understood what are we actually trying to do. We are actually trying to find the number of distinct subsequences possible and return that particular return string 1 if its number of subsequences, like distinct subsequences, is greater than or equal to distinct subsequences of string 2. Else return string 2. All right, so it's very basic question where basic understanding is just required here. Now the approach is what we need to discuss. How are we going to find the number of distinct subsequences possible? Okay, so now let us list out this particular thing itself. Okay, give an example itself. Every time whatever you're trying to do, use the examples that have been given. All right, try to find some conclusion from the examples, or try to find some pattern from the examples. Great. So coming to this particular thing, start from the 0th index, reach till this particular index, reach till the end index. Okay, so start from the start index like I equal to 0 and go up to I equal to 2. That this is the last. I equal to 2 would be the last. So what am I trying to do here? So basically at this particular I equal to 0, how many subsequences are possible? Only 1. And what is that? That is actually equal to G, isn't it? For at this particular I equal to 0, only 1 subsequence is possible. That is only G. Now come to this particular thing. Okay, now come to this particular thing. Here, how many subsequences are possible? 2 choices are there for F. What are the 2 choices? Even for I equal to 0, there are 2 choices, but we are not like take or not take. So if we take, I'll be getting G. If I'm not going to take, I'll be getting empty subsequence. But I'm not worried about empty subsequence as of now. I do not want empty subsequence. Okay, so that's not given in the question. We are only working on non-empty subsequences. Okay, so now coming to this particular F. So F has 2 choices. F can either be a part of G or do not be a part of G. Right? Every character has 2 choices in when you're trying to frame a subsequence. Either be a part of all the subsequences that are possible to the left of it, or do not be a part of any of the subsequence to at the part like forming that are forming to the left of it. So in that case, if F wants to be a part of the subsequences that are possible to the left of it, then the number of subsequence here there is a possibility of GF, right? GF, because F can be placed here because F is thinking to be a part of G, so GF is one of the subsequence. If F do not want to be a part of the previous subsequences, then F alone will be a subsequence. I hope you people understood, right? Because F has two choices: be a part of, not be a part of. If be a part of, GF would be the answer. If do not be a part of, F would be the answer. So done. And now coming to this, okay, I've just erased something. Fine. Now coming to this particular G. All right. Again, this G has two choices. What? Either be a part of all the subsequences that are being possible to the left of it. So what are all the subsequences possible? G, GF, F. Now for all these three, add G. So I would get G, GG, GFG, FG, right? So for all these three, I've added G. Now, what is the other choice that is there for G? Do not be a part of any of this, right? Do not be a part of any of this. In that case, what is the subsequence that's possible? Only G. Great. So in this case, in this manner, we are trying to find all the subsequences possible, right? We are trying to find all the subsequences possible. But here it's a glitch. Here there is a, something different. They have asked to find the number of distinct subsequences, isn't it? Distinct subsequences. When I listed out the subsequences for this G, I have got this particular element G. And when I've listed out this particular G, I've got this particular G. Why? Because this G has already been appeared once again, before, right? This particular G that I'm dealing has already been appeared before, long before, somewhere previously, before I come to this particular point. That is the reason there are particular subsequences that are repeating once again. Which are repeating once again? That are a part of this. Getting my point? So when I'm analyzing I equal to 2G, when I'm analyzing I equal to 2G, I found this particular subsequence to be repeating once again. I found this G here, but now I'm getting here as well. Why? Because at I equal to 0, we have dealt with G. We have dealt with the same character that I'm dealing at I equal to 2. So that is the reason there are subsequences. There are subsequences that are repeating at I equal to 2, because at I equal to 1, sorry, at I equal to 0, same character has been dealt. Okay, same character has been seen. So whatever the subsequences that are possible at I equal to 0, that again come at I equal to 2, isn't it? Again come at I equal to 2. We'll even do a different example, dry run of different example, you'll get better understanding. But right now it's very evident, right? Because at I equal to 2, I've got the same G that I've dealt at I equal to 0. So what are the possible sequences at I equal to 0? Only this. So that is the reason this is being repeated here. So what should I do? I must subtract this particular number. So what can I do is I'll be using a data structure. I'll be using a vector or a map. It's up to you. Vector is much more feasible because it's less space, just of 26. In the worst case, like if all the distinct characters are there. So I'll be just storing to this particular G. So whenever I finish this, I'll be storing that in the map or vector. Okay, vector. So I'll be storing like number of subsequences that are possible to this particular thing. So when I actually find the same thing, when I find the same G once again, when I come to I equal to, I find that the G has already been appeared. So the vector of G is no more 0. The map of G is no more 0. It has some value. That means G have already been, I've already seen G. So I'll be doing the same algorithm to count the number of subsequences possible, and I'll be subtracting the map of G, because map of G or vector of G stores the values of subsequences possible at I equal to 0. All right, at I equal to 0, the initial one. And once again, I'll update my MP of G or my vector of G with the total number of possible subsequences right now. That is this 4 plus 6, right? Because 3 plus 2 plus 1, total of 6 are there. I hope you people are understanding this particular thing. We'll even do another dry run. Okay, so just for better understanding. Okay, got it. So I'll be taking this particular example. Now let us take this particular example. Let us assume we have the string to be A, B, C, B, A. All right, let us assume this is the string that we have. Now what are the possible subsequences at this particular index? We have just A. Okay, and now what are the subsequences possible at this particular B? Either be a part of all these subsequences that appear to the left of it, so that would be A, B, or do not be a part. That would be only B. Coming to this particular C, we have again two choices: be a part of all the subsequences appearing to the left of it, or do not be a part. If be a part, then you have CA, you have AC, okay, and ABC and BC, right? And if you do not want to be a part, there is only C. Now coming to this particular element. Now when you're trying to analyze the two choices, first choice, be a part of all the subsequences appearing to the left of it. That means AB, ABB, BB, and ACB, and ABCB, and BCB, and CB, right? And what's the other choice that's left? Do not be a part of this, just B. Now if you carefully analyze here, you find the same B appearing here and here. You find the same AB appearing here and here. The reason being, because this is at I equal to 3. This is at I equal to 1. The character that I'm dealing at I equal to 3 has already been appeared at I equal to 1, isn't it? This is not the first time that I'm doing it. I'm analyzing B. I've analyzed B already at I equal to 1. So is the reason whatever the subsequence is possible at I equal to 1 appear once again at I equal to 3. I hope you people are understanding that. Okay, the same AB appears here as well. The same B appears here as well. The reason being, the I equal to 3, I'm also, when I'm doing for I equal to 3, I'm also putting this B to I equal to 0 element, and I equal to like individually is also I'm doing. So I'm trying to find all the subsequences possible to the left of it, and I'm adding that I equal to 3 element to all of the subsequences possible to the left of it. So I'm doing the same thing for I equal to 1 also. So that is the reason whatever the subsequences possible at I equal to 1 appear once again at I equal to 3. I hope you people understood. Now come to this particular I equal to 4. Okay, I equal to 4. Again, A has two choices. What are the two choices? Be a part of or do not be a part of. If you want to A to be a part of, you get ABA, ABBA, BBA, ACBA, ABCBA, okay, ABCBA, and BCBA, CBA, and BA, and what's the other final choice? Do not be a part of any of those things, then only A. Now see what are the things that are repeating. You have A here, you have A here. Alright. So the same thing that's been repeating, because at I equal to 0, you're dealing with and this is at I equal to 4. At I equal to 4, you're dealing with such a character, that's A, that's already been dealt before, that's at I equal to 0. So that is the reason whatever that is possible at I equal to 0 comes up here as well. So this is the duplicate that we are going to get. So we'll be deleting this. Okay, we'll not be considering this. So that is the only logic here. I hope you people understood like this dry run of this example. So we can go with the further code. So only like firstly we have distinct 1 which tells that okay, distinct 1 number of distinct possibilities for string 1, and distinct 2 which tells the number of possibility for string 2, and return distinct 1 greater than or equal to 2, then return string 1, else return string 2. Now what is distinct doing? Gives the number of distinct subsequences. How it's going to do? So vector in previous of 26,0, this is the vector that I'm using to store the number of distinct subsequences that are possible for that particular element. So in total equal to 0, that's the total number of subsequences that are possible for the whole string. Okay, so that would be the final answer, total number of distinct subsequences. For int I equal to 0, I less than s dot length I plus plus, in present equal to total plus 1, right? So when you're at this character, like let us assume A, B, C, B, A is a string that you have taken. At this particular thing, number of things that are possible is present plus 1. What is present initially? That is 0. So this would be 1, right? So why 1? This is actually A. Only, all right. When you're at only this particular index, number of distinct subsequences possibility is only A, isn't it? So that is present. Present denotes the present possibility. So that is only one possibility. So that is 1. Total plus 1. 0 plus 1. That is equal to 1. And now previous of S of I minus A, if it exists, that means in the map, if it is not 0 and it's having some value, that means you need to subtract. You need to subtract that, right? You need to subtract that. So if you do not have that, if it is actually 0, if that means this is the first time that you're visiting, then add the number of possible subsequence at that particular point that is present to the total value. That is the answer, right? Total is what I'm carrying as the answer. So at every character I'll be analyzing how many number of distinct subsequences are possible for that character, and I'll be adding to the total value. All right. And now previous of Si minus A is present. Now I'm updating my map. So why is int present total plus 1? So if you're at this B, what are the two choices that are there? Either be a part, or do not be a part. Do not be a part. If you wanted to be a part, so whatever the number of possible subsequences that are possible till now, add that to B, right? So that is there in the total, right? So total when you're coming to this B, total is 1. Total is 1. You did not still start with B. When you're just standing at the B, your total is 1, because total denotes number of subsequences possible to the left of B. And now because you're adding B to all of them, like you want B to be a part of it, so it will be 1 and plus another 1. Why? Because I do not want to be a part of I do not want B to be a part of all of the subsequences appearing in its left. So that's the reason I'll be only having one more subsequence possible. So total 2. Now when you're coming to this C, you have total to be 2, and C has two options again: be a part or do not be a part. It can be a part of all the two subsequences that are appearing before it. So that is 2, plus it do not want to be a part of it. That is 1. So total 3. I hope you people understood. That's the reason we are doing in present equal to total plus 1. And once if it is actually appearing again, remove the previously occurred subsequences possible for that particular character. If it's not appearing it's appearing for the first time, then you just do total plus equal to present and update that particular character vector with the number of possibilities. Like present denotes the number of possibilities, number of distinct subsequences possible for that particular character, right? Particular character. That's it. That is what it's going to denote, and return total at the end of the day. All right. I hope you people understood what are we trying to do. It's very evident. If you do not understand, please watch it again. I hope I've tried to put all the things much more clearly. So it's just the basic thing that we are doing using completely the logic. Either be a part, do not be a part. If be a part, add all those left things, that is total that you're storing in, plus if you do not want to be a part of, then it will be only 1. So total plus 1 is your present number of subsequences possible. Now you're evaluating how many of them are unique. For that, it will go to if or else. If it's going to if, that means it's previously been evaluated, it's previously been counted once long back. So I'll be subtracting the possibilities at that particular thing, so that I'll be getting the unique ones right now. If you're dealing it with the first time, that means all of the present that you have are unique. So you'll be adding it down to the total. All right. So I hope you people understood. So for your reference, codes in Java, Python, C++ are given in the description. Please go through them. There are some internet issues, so I'm not able to submit it as of now. So if there are any doubts, please feel free to comment in the comment section. I'll be more than happy to revert back to you. And please go through the video properly. And yes, I hope you people actually enjoyed watching this video. Thank you for watching. Stay tuned.